All right, last page of the the atomic compounds notes. We're going to do some practice and get you ready so that you can do your practice worksheets for our naming and balancing charges of ionic compounds. So we have 5 examples here. You already know the first one. The first one we've already done. It's called sodium chloride. But let's do the second one together. Right now we're just naming them. And so if you don't remember how to name them, you remember the first rule of metal and ion has its regular name. The second ion, the nonmetal, has you change the ending to be "ide." If you don't remember that, you can use your periodic table of ions and notice, for example, that for calcium bromide, or CaBr, the bromide is right here, BrOMIDE. That's the bromide ion. Calcium stays the same, so we're just going to name this calcium bromide. And you can do the others as practice. You'll probably notice that as you're doing these, some of these terms are very familiar to you. So you might know of a compound that has an oxide in it, for example. So you can think about that as you're working. All right. So let's do the little check-in here, which is to combine aluminum, sulfur, and then find the name for aluminum and sulfur. And so to do that, we'll find on the periodic table of ions, we are going to find let's move that up to the top. We're going to find aluminum. We've seen aluminum before. Here's aluminum right there. It has a charge of 3+, so I'll put aluminum 3+ right there. And then in this case, we're doing sulfur, and sulfur as an ion has a charge of 2-. Notice also that sulfur is called sulfide. So we can name it already, which would be aluminum sulfide. And you didn't have to do what I did here, which is to capitalize the first one. They should actually both be lowercase. They're not proper nouns. So aluminum and sulfur. So now we have our charges. Aluminum has a charge of 3+. Sulfide has a charge of 2-. This is where we need to take a look at finding the balances of charges. So 3+ and 2-. We want to find a multiple that these both go in. The easiest one is going to be 6. They both go into 6. So 3+ goes into 6 plus 2 times. 2- goes into 6- 3 times. And so what that looks like is we have 2 aluminum, Al2, and 3 sulfides, S3. And that is a balanced compound there with 2 aluminums and 3 sulfide ions, and those charges will balance out, and that's the correct name. Okay, 2 little rules I want to show you, really 1 rule that I want to show you if you're doing Honors Challenge. If you're not doing Honors Challenge, you can just watch, but in the case of some of these metals, we talked about how the middle metals in the transition metals, they have some confusing charges. And you can take a look here. The nice thing about this periodic table is it tells you what most of the charges are for these metals. And these metals we can call metal ions with multiple charges. Take, for example, chromium. Chromium's right here. Chromium is a metal that sometimes can be found with it as an ion with 3+ as its charge, and sometimes can be found as an ion with 2+ as its charge. And so what we need to be able to do is first know how to write those to distinguish between them. And secondly, we need to know how to determine which ion we're talking about if you have a compound. So for example, let's start by recording the chromium charges and give an example. So chromium, let's do the example of chromium sulfide. So we can actually have, let's do this. Chromium sulfide, we can have 2 charges. We can have chromium 2+. Let's do that one first. Or we can, and then sulfide, which is 2-. So chromium 2 plus and sulfide 2 minus, well, that's going to be an easy one to figure out in terms of the chemical formula. So it'll be CRS. But what will we name that? Well, we're going to name that chromium. Let me spell that correctly. Chromium. And instead of just chromium sulfide, to distinguish that this is a 2 plus charge, I'm going to write chromium and then in parentheses Roman numeral 2. And that tells me that we have a 2 plus charge on chromium. We're talking about the chromium ion with a 2 plus charge in this case. So let's take a look at the difference between chromium 3 plus. So chromium 3 plus, sulfide's still 2 minus. So I could take a look at, okay, if this has a charge of 3 plus and this one has a 2 minus, this is just like our problem above where we need to figure out, okay, this is going to go into 6 plus, that's going to go into 6 minus. This means it's times 3, that means it's times 2. So we'll have Cr2 S3. That will be our formula for this compound. And the name of this is still going to be chromium sulfide, but in this case, to distinguish that this is the chromium 3 ion, we put that in parentheses. So Roman numeral 3 right in parentheses for chromium sulfide. You could do another example with a polyatomic ion. So we'll do one more example here. This example I'm going to write out as iron 3 nitrate. And right away I'm thinking, oh, 8, that nitrate piece, that's different from iod. So I'm going to look for nitrate on my periodic table. I'm also going to look for iron 3. So nitrate, remember I said these were going to be in alphabetical order. We can find nitrate right here. Be careful with nitrate because look, there's something called nitrate and then something right below it called nitrite. We want nitrate, NO3 minus. So we're going to write that down. NO3 minus. And then we also want iron, what did I say? Iron 3. And so iron 3 is right here. It has a positive 3 plus. So iron Fe3 plus, NO3 minus. This is one of those polyatomic ions. So this thing acts like one piece. So right now its total charge is -1. This has a total charge of +3. And so we want those to be balanced. To do that, we're going to just need 3 of these guys, right? So we need this times 3 to get this to be 3 minus. And so we need 3 of these nitrates right here. We need 1 of those irons, so it's going to be Fe, parentheses. The parentheses in the case of the formula tells us that we're going to need however many of these things inside the parentheses. So we're going to do the NO3 inside. And then how many of those do we need? Well, we need 3 of them. So this is the chemical formula for iron 3 nitrate. This is the hardest type of problem that you'll see in your examples. So if you are doing some practice, that's your next step. You're going to be working on this purple sheet here that has practice. Let's zoom out a little so you can see. This purple one has some practice for you to work on, both finding what the chemical formula is and to find the compounds and writing that this case it wants you to write the ions and the number of each ion in the model. You should be all set. And then on the back there's more practice again with polyatomic ions, and don't forget to look for those on your periodic table of ions. All right, good luck. I hope it goes well.